Or in this video, we're going to solve another what I call beam problems that require you to write equations using assumptions about static equilibrium, not assumptions, but theory about static equilibrium, and also sum of moments. Okay, so let's get started with that. All right, so in this example, we're going to assume the beam has negligible mass compared to the forces that are being used, which I should write those in, by the way. Let's say we have 420 pound force for this first force in red, and the second one is 640 pound force. All right, so we're neglecting the mass of the beam, and we want to adjust this weight W. I should also tell you what that is. Let's see, let's use that this weight is 180 pound mass. Okay? All right, so we adjust the horizontal distance x so that the reaction forces at points A and B are equally distributed. Okay? All right, you get the gist of the problem? All right, adjust this positioning of the weight, and we get equal reactions at A and B. All right, so the first step, of course, is the free body diagram. So let's draw that. All right, so if I draw a free body diagram, I'm going to make that in blue. Okay, so here's the beam. Okay, and we notice there's a pin at A, so we would have, I'm just going to call it AX and, AY, and AX are reaction forces. Okay, and at B we would have a reaction force B. It's only in the Y direction because it's a roller. A roller can only exert a force that's normal to the action of the roller. Okay, and then we have our forces, the 420 and the 640. Let's put those in. 420, 640, and we have our weight, and it's a 180 pound mass, but we convert that to pound force, which is easy in the English system. It's just the same thing, or the same numerical value. And now we put in some of our dimensions. I'm going to put that in black, all right, with a thinner line. All right, so our dimensions here, we have 3 feet, 6 feet, and then I think to the end of the beam is also 6 feet. All right, and I didn't put that mass in yet. Okay, so, oh yeah, I did. All right, that's it. That's that distance is going to be x. We don't know what x is. All right, so let's get started. What we know is sum of forces in the x direction, sum of forces in the y direction, sum of moments about any point are equal to 0. That's our starting point after we get, of course, we first do the free body diagram. But, part of the trick of learning to become an engineer is asking the right questions. And so I always ask myself, what do I know? I know these equilibrium equations, and I know sum of moments about any point needs to be 0. So I can start writing equations. And my idea here is to try to write enough equations so that I'll be able to solve the system of equations. All right, so generally, if I have 3 unknowns, I'm going to need 3 equations. All right, so let's get started with that idea. All right, so first of all, I'm going through my process, sum of forces in the x direction equals 0. All right, I'm only seeing AX. All right, so AX is the only force that's acting in the x direction, and so that needs to be, well, that turns out to be 0. All right, so there's no horizontal reaction force at the pin because there's only vertical forces acting on the system at that point. Okay. All right. So next we can do sum of vertical forces. All right. So I'm looking here, and I can highlight all these forces. There's one. All these are forces in the vertical direction. Okay, so I write those down, and I would get, sum of forces in the y direction, where y is up, being positive. Okay, I would have AY is going up. All right, then I have minus 420, minus 180, minus 640, plus B equals 0. There's one equation. Okay, we have a couple of unknowns still. All right, so let's move forward. We know we're going to need another equation. Okay, so we've already exhausted sum of forces x, sum of forces y. So that means we need to do the sum of moments about some point. Okay, and I think it makes sense to use either point A or point B, all right, because if we do that, one of the variables drops out. Okay, so let's use point A. We're going to do sum of moments about A equals 0, where counterclockwise is positive. Okay, so I start to take a look at these one at a time. Let me clear these. All right, so let's take a look first at the 420. So 420, the perpendicular distance is 3 feet. Okay, and so 3 feet, 420 working down, that's going to give me a clockwise motion. Okay, so I would put down that this moment is going to be 3 times 420. Okay, so next let's take a look at the 180-pound force and the moment generated by that. Okay, well, the moment arm is x, all right, and then so this would be x times 180. All right, and now we ask ourselves, is this clockwise or counterclockwise? And this would be clockwise, so that gets a minus sign. All right, then we look at the 610, the moment arm. Looking at the moment arm, that would be here. Okay, so that has a distance of 9. The force is 610. All right, and this would also be clockwise, so that gets a minus. Okay. Next, and the final one would be the force at B. The force at B acts up. All right, the total moment arm length would be all of this. Okay, so 9 plus 6 is 15. All right, so this would be 15 times B. And because this would generate a counterclockwise motion, this gets a plus sign. Okay. All right, so good. That gave us another equation, but unfortunately we also came up with another unknown. We don't know x. All right, so I'm thinking, I've done sum of moments, I've done sum of forces in the x direction, sum of forces in the y direction. I have essentially, I'm not counting this first equation. That one's trivial, all right? That one is, we already know that. So We don't know AY, we don't know B, we don't know X, all right? There's two equations, we need a third equation. And of course you go back to the problem statement and, yeah, we know that AY is equal to B. That's the constraint that we have, and that gives us our third equation. Okay, so with that, we have essentially, we can substitute back in, and we would only have, well, we have three equations, three unknowns. We can solve that. So at this point, I'm looking at how to solve these three equations, three unknowns, and of course you can do that by hand, but I've emphasized that there's a separation between writing the equations and solving the equations, and I feel like it's perfectly valid to use computer tools to solve equations. We're trying to concentrate on the theory, and so while I want you to be able to solve equations by hand, and I think you should practice that by hand quite a bit, I also want you to be able to check your answers using something like MATLAB. Okay, and so here is the code that is written for that. You don't have to know about computer coding because these are pretty simple kind of commands, and if you just follow the syntax, you can do this kind of check yourself. All right, so in general, the way I like to do things in MATLAB is to try to use variables whenever I can, whenever it makes it easier. And so I looked at the free body diagram and I put in some initial parameters, like that first distance was 3 feet, the second was 6, the third one was 6. I put in the forces, the 420 and the 640, and I put in the weight, 180. Okay, then I came, this is a variable. I call it EQ1. You could have called it dog. All right, it doesn't really matter. It's just a variable. This command is essential because it's telling MATLAB, hey, I want to do some symbolic calculations. Symbolic calculations are different than normal programming. I know you haven't had a lot of experience with normal programming, but don't worry about it. You can use MATLAB without knowing all the details of what's inside the, under the hood, so to speak. Okay, so I write the equation. I don't need any quotation marks or anything. I just need to write them in terms of variables that I've already defined. Okay, so you notice I've already defined a y as a symbolic variable. That's one of the unknowns. Okay, so that's what I'm thinking here. I defined the symbolic variables as the unknowns. I've got the variable b in there. It's also unknown. But I have some other variables. W is the weight. F1 is this force, and F2 is the other force. Okay, and so you see, you put that equation in, and MATLAB substitutes the known things and leaves the unknowns and collects everything together, and shows you the equation. All right, I did the same thing for the second equation that we wrote, and for the third equation. Right, the third equation was trivial. AY is equal to B. All right, so next what I do is I use the solve command from the symbolic toolbox of MATLAB. Okay, so you noticed I had three equations, so I just list those, 1, 2, 3, separated by commas. And then I list the set of unknowns, and I called this output a variable. Okay, it's actually a structure. All right, you don't need to know anything about structures to use them. Okay, however, you do need to know that to access a part of the structure, you put the variable name and then you put a dot, and then I have these three unknowns, so there's going to be an s.x, there's also going to be an s.b, and there's an s.ay. Okay, I didn't ask for s.ay because I know that ay is equal to b in this case. All right, and then we've already talked about this. VPA stands for Variable Precision Arithmetic. This is what lets me substitute back in and clear the thing of fractions to where I get numerical values reported back. All right, so I limited that to 3 significant decimal places, and so this is what I get for the answer X, and this is what I get for the answer B. Okay, you can do that by hand, and I encourage you to do this by hand so that you do sharpen your equation solving skills. But you see my point. If you do it this way, you can write the equations real quick, check your answers, and then if I give you some answers to check against. But you can check your answers this way without having to go through all the tedium of solving the equations. If you've written the equation wrong, it's going to take you a while to solve it to find that out, so this can shorten that path. Okay, so I wanted you to be aware of that, and it's something you can use on quizzes and homework, and just a tip for you.